Hello students, welcome to the NPTEL course, Practical High Performance Computing. I am Mahendra Verma from IIT Kanpur. I work on HPC, physics, CFD, and so on. So this is a course on HPC, High Performance Computing, which here we will cover lots of topics. So we start with HPC systems, GPUs, graphical processing units, which have become very critical, very important for HPC. These are hardware parts which we need to know for optimized computing. Then we also have, then I will introduce what is HPC paradigm. So for example, a good program should scale well. That means if I increase the number of processors, the time should decrease proportionally. We'll also give basics of Python and C programs. In fact, it turns out that using compiler optimization without writing parallel codes, we can get good speed up. So there are some tricks like vectorization, which I will cover in this part of the course. Then we will cover traditional MPI tools, traditional parallel programming tools. That includes MPI, called message passing interface. So here lots of processors, and then how to run one program on all the processors by dividing the work equally. And so there are some paradigms, there are some tricks which we'll learn. Then OpenMP, this is for shared memory architecture, and OpenACC. Okay, so we'll cover these paradigms, or these tools for writing parallel programs. So parallel programs are ones which will run on more than one processor. So if you have, let's say, 50 processors, we can use these tools to run on that machine. So these tools, MPI, OpenMP, OpenACC, are typically for CPUs. Okay, that was the case for 5 years back. Most programs were running on CPUs. But of late, GPUs have taken over. So like top 10 machines in the world, top 10 high performance computing platforms in the world employ GPUs, all top 10 of them. Okay, so just to give you an idea, the GPU has more than 6,000 cores in comparison to CPU, which has around less than 100 cores. Okay, so with cores which are that many, we can speed up our code hugely on GPUs. So how to program on GPU? So it does look a bit scary. The standard paradigm in early times was CUDA for NVIDIA GPUs. So we'll cover CUDA. But writing CUDA codes does require patience. It is in either C in Fortran, but in our codes we'll cover in C. But it turns out using Python, which is simpler to code, so using Python, we can run our codes in GPUs. So the two popular tools are CuPy and Numba CUDA. Okay, so I will cover them. So it turns out the Python codes are much smaller, and if you do it properly, it can give as good speed as C codes. So these are large number of topics that will be covered in the course. So the course has a lot of practical component, but it also goes fast, and we can't get deep into one topic. So I cover one topic in 2 hours out of 30 hours or 2-3 hours. Okay. Now, why HPC and why this course? So there are courses on HPC which may cover either hardware or MPI programming or OpenMP programming or only GPU programming. In this course, I try to cover all of them, but not as deep. So, and also compare them. So you exactly know what are the benefits of GPU programming or CPU programming, um, or given a problem, what should I choose? Or given a hardware, what tools I should use. So I will cover modern hardwares, including GPUs. I mean, GPUs in this course are around 30%. The 30% of the course is covering GPU. We also have modern programming language. Well, Python is not today's language. It has been around for a while. But Python for HPC is very new, reasonably new. So Coupa is still developing. So we cover it, and it turns out it's pretty nice tool with very small amount of work. You can get your code on GPU. Numba CUDA. Okay, so we'll cover CUDA, HPC, and Numba CUDA in this course. But we'll also cover traditional tools. So if you have CPU platform, CPU based HPC platform, you can use MPI, OpenMP, OpenACC. So we'll cover lots of topics, and I hope you'll enjoy them. I strongly recommend that program these codes on Google platform. So we will share these codes with you, and you can run it as it is and modify it and uh, kind of get a hang of these codes. So I hope you'll enjoy this course, and good luck, and uh, we'll keep discussing in between in discussion forums. Um, so you can please feel free to ask questions during in the forum or by email. Good luck and enjoy the course. Bye.